All right, so we have this method to be able to do long division with polynomials. We have this method called synthetic division. And synthetic division is basically something that allows us to say, hey, I want to divide. So like if we start off, we're looking at this guy right here. Essentially what it's saying is it's saying, okay, I have this, I'm just kind of moving some stuff around. So it's saying I have this polynomial, x cubed plus 3x squared plus 7x plus 5, and I want to divide it by x plus 1. All right, so I mean, we could do that. We really could. It's a little more complicated, because once you divide, and you got to carry things over with the plus 1 and so forth. But we have a method instead called synthetic division. With synthetic division, what we do is I use an upside down division bracket. And then you take and you put your leading coefficients, into these brackets. So that would be 1, 3, 7, and then your constant of 5. Down below your constant, you draw a little line, and that little box right there is where that whatever comes out right there will be your remainder. Okay, we'll talk about that in just a minute. So once again, as you set this up, you're going to draw the box so that you'll have two lines, line 1, line 2. We're going to put some numbers in right there, okay? We use what's called the factor theorem, and the factor theorem says that if you have a factor like x plus 1 and you set it equal to 0 and you solve that, you get x equals -1 as a possible solution. So we use the factor theorem to make that factor into this possible 0 or possible solution. Okay, so there's our setup. So from there, we start off and we bring down the 1. All right, then we take the 1, the -1, the number out in front, we multiply it times the 1, and we put it right there, we get -1. Unlike regular division, instead of subtracting right there, we add, and we get +2. We multiply again, so -1 times +2 gives me -2. We add, we get +5. We multiply -1 times +5. We put it right there. We get -5. And we add one last time. We get a remainder of 0. So what we've just found out is a couple of things. We found out, according to the remainder theorem, that if we take the function and we evaluate it at -1, we'll get a remainder of 0. So think about evaluating functions and plugging numbers in. They're saying that if I plugged in -1 into this function right here using my calculator, so I just came here with my calculator, went to my home screen, and said, let's see, -1 quantity cubed plus 3, -1 squared plus 7 times -1 plus 5, that I will get 0. So that's what the remainder theorem says, is that we could be doing this synthetic division to find that. Well, we have a table, so we want to find that out. We can just go right here and look. Oh, at -1 I get out 0. At +1 I get out 16. So that's the same thing synthetic division will do according to the remainder theorem. All right. The other cool part that we found out here is that we took this guy right here, we divided x plus 1 into this right here, and we came out with x squared, 1, plus 2x, see the 2, plus 5. So we know that the quotient of this guy is x squared plus 2x plus 5 by using this method called synthetic division. All right, let's take a look at the next one real quick. So same thing, we set this guy up, we'll skip right out, we won't write down, we won't write this part in there because we already have the idea. So we'll go right into the synthetic. So we got coefficient of -8, +7, -6, and +3. Our factor is x minus 2. So we take that down there. That means our solution would be +2. Our possible solution that we're going to test. We test it. We bring down the -8. We multiply the +2 times the -8. That gives us -16. We add, that gives us -9. We multiply, we get -18. We add, we get negative 24. We multiply, we get negative 48. So let's go back through and check those numbers because that didn't work out and I thought it was going to. So negative 8, 7, negative 6, 3. Negative 8, 7, negative 6, 3. The factor is negative minus 2, so the 0 will be positive 2. We bring down the 8, the negative 8, we multiply, we get negative 16. We take the 2 times the 9, right, because we added those together. 7 plus negative 16 is negative 9. We take the 2 times the 9, we get negative 18. We add, we get negative 24. We multiply, we get negative 48. We add, and we get negative 45. So according to that, that means in this case here that x minus 2 does not divide evenly. X minus 2 does not divide evenly into this polynomial. So, but what does that mean? Like, what does that mean for what we have here? Well, it means that according to the remainder theorem, if we did f of 2 with this function, we would get out negative 45. And it means something more than that. It means that I can actually find the quotient for this. My quotient for this guy, let me move the remainder theorem out a little bit further over. So that means for the remainder theorem that if I did f of 2, I would get negative 45. But that means for my quotient, I still divided it in. I still divided it out. I got negative 8x squared, minus 9x minus 24. But then I have a remainder. So like that's being the remainder right there. I have to write the remainder in. So we say plus, and we put the remainder over what we originally divided by. So we put the remainder over what we originally divided by. So remember that if we went back into this thing and we actually wrote it out as, like I said I wasn't going to, but I'm going to do it real quickly. If we actually went and wrote this out as negative 8x cubed plus 7x squared minus 6x plus 3, what we're saying is that we've got our polynomial, negative 8x squared minus 9x minus 24 plus this remainder. Now, I want to remind you of something real quick. If we divided 7 into 37, we have several ways of writing this. 7 doesn't go into 37, so we still put a 5 there. So we still have a divisor, just like we have a divisor down here. We still have a divisor that goes into it. 5 still goes into it. But then once we divide that out, we find out we get 35 with 2 left over. So we have a remainder at this point. So right now we have this remainder, just like right there. Well, to write this guy, we write it as 5 and 2 sevenths as a mixed number. So remember, 5 and 2 sevenths. So I'm trying to make like some kind of a association that you might have from something else, and you divide it by 7. Well, in this case here, we divided by x minus 2. So that's why when we put this guy in our final solution here, it's going to be the quotient plus the remainder over the divisor. Because it follows what we've done in long division. So that you have your quotient, your remainder, and your divisor. 5 and 2 sevenths. The only difference is here is that we don't put a plus sign, do we, on a mixed number. But if you listen to the words 5 and 2 sevenths, it sounds like to me you're saying the word and, which means to add. So that's why the addition sign is there. All right, so there's our synthetic division on a couple of basic things. We'll move on from there.